Okay, let's talk about exponentials. So an exponential function would be a function that looks like y equals some number times b to a base to an exponent x. For instance, y equals 3x times 2 to the x. If I were to make a graph of this, if I put in 0, 2 to the 0, I'll make a table here, put in 0, 2 to the 0 is 1, times 3 would be 3. 2 to the 1 is 2 times 3 is 6. And 2 to the 2 would be 4. 2 squared is 4 times 3 is 12. And 2 to the negative 1 would be 1 over 2, or a half times 3 would be 3 halves. So at minus 1, it's 1.5. At 0, it's at 3. And minus 1 at 1, it would be at 6. 3, 4, 5, 6. And at 2, it'd be off my paper, and it's going to do something like this. And it's never going to go below 0 because it's always going to be positive number, power to positive number. It's going to look something like that. That's what an exponential looks like. Okay? And this one is a growth one because it's going up. Now, we could move this around by sideways by adding or subtracting from the x. We could stretch it or shrink it by multiplying the x by something, just like we did before. We can multiply by something besides 3, maybe 4 or 5, stretching it, or a half of a quarter. We could do a negative and flip it over. All that stuff that we did for translations, transformations, still works. Okay, now let's say, what kinds of things do exponential? Well, a lot of things are growth things that grow exponentially. Okay? So, what if we had to make a model of something going through a couple of points, like 0, 5, and 3, 30. Well, if it's y equals a b to the x, if x was 0, b to the 0 is 1 times a, and if I'm putting in 0, I'm supposed to get 5. This would tell me a is 5. This is a y-intercept, and a is always the y-intercept. So the equation we now know so far would be 5b to the x. And if I said put in the 3 for the x, I'd get b to the third times 5 would have to be 30. Then divide both sides by 5. And I'd get 6 equals b to the third. And to get rid of the third, I'd take the cubed root. And I'd get b to the 6 to the cubed root was 1 divided by 3 power, 1/3 power. And it would be a base of 1.817. To the x times 5 equals y. And if I type that as an equation and put in 0, I should get 5, because this, any number to 0 is 1 times 5 is 5. And if I put 3 in there, if I take this to the third times 5, I should get my 30. Not 30. Oh, I didn't do times 5. I messed that up. that number to the 3, get out of there, times 5, I should get 30. And I did. Now that I did it right. Okay. What if these points are not as nice? What if they're like, oh, -2 gives 5, and 3 gives 30? Okay, so this gets a little trickier. It says if I go from here to there, there's some kind of starting amount, some A, times my base, and the base has gone from -2 to 3. That's how many steps. -2, if at -2, I'm supposed to multiply by the base. A times the base will give me supposed to give me 5. Then when I'm at -1, I'm going to multiply by the base one more time. So I'm going to, times base no times. A times the base once will get me to the next place, which I don't know. And then 0 times A times the base to the 2. I've moved up. I had to multiply. Every time I do this exponential, I just keep multiplying by the base more times. So I'd be multiplying by this number times the base to get to this number, or this number times the base to get to this number, times the base again to get to this number. So let's just do it this way. If I start at 5 for -2, then I'm going to have to be 5 times the base once to get to this number, 5 times the base a second time to get to the next number for 0, and 5 times the base another time to get to what it is at 1, and 5 times the base another time to get for 2, and 5 times the base another time to get to 3. To go from here to here, I've got to multiply the base 5 times this to get to that. And so this was 30, so I have 5 times the base 5 times, from -2 to 3 is 5 times, is supposed to give me 30. So if I divide by 5, I get 6 is the base to the 5th. To solve for that, I take the 5th root of both sides here, and I find that my base, x to the 5th root, 1/5 power, my base has got to be 1.43. So my base is 1.43. 2x times some A is supposed to make this work. If I put in -2 for the x, I'm supposed to get 5. So now, if I put in -2, I can figure out what A is. So I'm going to put in this to the -2. Oops, that's not minus. -2. And that number, 0.4883 times A is supposed to give me 5. So I'm going to divide 5 by that answer. 5 divided by that answer. And I get 10.238. 10.238 times 1.43 to the x is supposed to be my y. This should work for both of these points. Let's check that. I'm going to go to my y equals, delete, clear this one, 10.238 times 1.43, these are rounded, close parenthesis, to the x power. And then I'm going to go to second table, and I have it on second table set. I've got it on ask on the table set, so I go to the table, and I can put in -2, and it says about 5. Remember, I rounded, so that's going to be approximate. And if I put in 3, I should get about 30, 29.93. So this is a pretty good model for an exponential going through those 2 points. That's how you can get an exponential function. Now let's talk about compound interest. Okay, so to understand that, if you could have simple interest, that's not compound. If I put $100 in the bank, and let's say it's got 2% interest, that means after 1 year, 2% of this will be added to this, and I get $100 plus the 2%, which is $2. I have $102. And after 2 years, I don't get 2% of this. I get 2% of my original number, so it's be 102 plus $2 is 2% of the original, and I got $104 in the bank. Not making a lot of money, but that's simple interest. Now, compound interest, if I do it annually, I take my $100, and after 1 year, I take 2%, if it's 2% annually, 2% times this, and I get $2, and I add it to my 100 that I already have, and I have $102. Now, the second year, I take 2% of this, which is $2.04, and add it to my 102 that I already had, and now I have $104.04. So I have a little bit more. And if I compound monthly, then I'm going to do, at the no months, I'm going to have, and this is going to be 2% annual interest, I'm going to have $100. And after 1 month, which is 1/12 of a year, if you will, 1 month, I'm going to have $100 plus 1/12 of 2%, so 0.02 divided by 12 times 100. That'll be my interest on it after 1 month, added to this, and I'd have my new amount. Then after 2 months, and I'm going to have to go clear to 12 months to have my 1 year. And I would have had to taken. So now let's figure out how to do this more easily. So going back to here, I'm going to have $100 at time 0. After 1 year, I want to get 102 without having to do this add thing. Well, I've been taking 100 times 0.02 to figure out the $2. And then I'm going to also have the 100, so I'm doing all of my money, 100% of it, plus 2% more. So I could have gotten these numbers by just multiplying this by 102% in decimal form to get the next number, and times 102% to get the next number. So on the calculator, that would look like $100 enter times 100% and 2% more, 0.02, And I'd have 102 after a year, and then I'd have 104.04, and enter. I have it after another year, and another year, another year, another year, another year. And I can figure out how much I would have after 10 years, or 11 or 12 or whatever, and just keep entering, and I keep going up. So how are we going to do it on this one? So we're going to do $100, the starting amount. That's sometimes written as amount at times 0, times I want 100%. 100% in decimal form is 1, plus my interest rate, which was 2%, 0.02, divided by how many times I'm doing this a year, 12 times a year. I'm going to multiply 100 times this, 100, enter, times 1 plus, put it in parentheses, 1 plus 0.02 divided by 12. And if I do that, that's how much I'd have after 1 month. Gain 16 cents. And after 2 months, now I'm at 33 cents. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice that I don't have 102. I have a little bit more than 102. 102 and almost 2 cents. And after 2 years, another 1 month, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's another one. I'd be at 104 and 7 cents instead of 4 cents. 8 cents. So I get a little bit more. So now let's turn this into a formula. Compound interest. The amount that I have after some time is the amount I start at the beginning at time 0 times 1 plus my interest rate in decimal form divided by how many times I'm going to get my interest in a month, be it 12 or once a year, n would be 1, 12 times a year, monthly, n would be 12. So times n times the number of years. So what if I had $100 in and got compounded every day? Then I'd have 1 plus my interest rate, 0.02 if I go back to my problem. But every day, that's 365 times in a year, to the 365 times the number of years. So doing this, I can type it in like this, 100, parenthesis, 1 plus 0.02 divided by 365, close parenthesis, to the, and if you're using the older calculators, you got to put the exponents in parentheses, but this raises it up so it's like parentheses, 365 times the number of years. So I could put in 1 and find out, times 1, and find out how much I would have after 1 year doing it daily. And I'd have 102 and 2 and a little bit more than 102. And after 2 years, I'd have to change the 1 to a 2, and it would be 104.08, not 04, so I'm doing better, and keeps getting better and better. And after 3 years, I could go back here and change this to a 3, and I got 106, and I can keep going like that. Okay? So this is the compound interest rate. If I was compounding interest quarterly, n would be 4, annually, n is 1. Simple interest, different. What if I was doing it every second? I'd have to figure out how many seconds are in a year, and I could do this. But that's awfully often. It's almost like doing it continuously. So compounded continuously, there's another formula. It's the amount after some times equals the starting amount, same thing, and this crazy number e to the RT. R is the interest rate. Now, E, what the heck is it? Now, you know pi is the number of times a diameter of a circle fits on the circle. 1, 2, 3.414 pi. Pi is not just 3.14, it's 3.14159, blah, 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 blah. Well, E is another number like pi that shows up in mathematics. It becomes of interest when you're trying to draw an exponential where, like population, the amount of population also predicts how fast it's changing. In other words, population growth depends on the number of people. Well, the only graph where the growth is equal to the number of people is e to the x, and e turns out to be a number where it's 2.718281828459045. That's what e is, approximately. It's a number like pi, and it's also found like pi is. Pi's got its own special key here. E has its own special key right there. And e to the x has its own special key right there. So, if I go second, divide, you'll see e, and it's 2.718281828459045. You don't see that last part. But anyway, using e, we can, and this formula, we can figure out how much I would have in the bank if I started with $100, starting amount. E, my interest rate, 0.02 times t, the number of years, will tell me how much I would have after some years. So I'm going to type this in and just see how that compares to my other answer. Compounding it daily, I got $106.18. So now I'm going to type in 100 e to the 0.02 times, and this was after 3 years, so I'm going to go times 3, and it turns out I would have 106.18, not 4, but 6, slightly more if I compounded it continuously. And that's compounded continuously interest. All right, that takes us up to Friday, and I'll do Friday's lecture on Monday for you.